Hello, my name is Andrew Brooks. This is another presentation of Nonlinear Existentialism, the THAM processor, engineering aspects of human thought. You can see the table of contents. The starting point here is the THAM processor. Before this, we're talking about thought. Thought is equal to nonlinear change, which is instantaneous incongruency, and integration. Basically, what THAM stands for is Frequency Amplitude Modulation, and the THAM symbol you can see is the bottom right. Basically just taking what was mentioned for the V1b, the layer V1b in the cerebral cortex, and how it does frequency as well as amplitude modulation, and this is what caused thought, which is going to be the change and integration of the electrochemical signals that are produced in the human cerebral cortex. This is going to be, as beforehand, with the idea of energetics, and this is the fundamental of the energetics. I'm just going to read Principle 1 and comment on some others as we go through. But the most important one is going to be Principle 1. Physical and chemical associations between neurons and neurites in the central nervous system form neurophysiological patterns. These patterns link external energy states to internal energy states. And we have here before just mentioning again the importance of the primary needs baseline activity level. The system naturally tends towards this energy level, however it is often unable to achieve it because it is inhibited by incongruencies that occur in between the neuronal patterns stored in the central nervous system. And this is Principle 3 talking about the primary needs baseline activity level and also the non-optimal wants baseline activity level. So we also have number 4. And again, just going into the principle of how primary needs baseline activity level, how it corresponds and relates to the non-optimal wants baseline activity level. The other thing that's being brought in here is the idea of the triggering energy difference. And this is going to be what causes a response beyond the baseline activity level. And how the TED gets activated. The number and type of patterns that respond to TED depends on the uniqueness and importance of the event that caused it to occur. So TED is going to be more, if you've got something like a basic situation where it's a negative feedback loop and it's been going on over and over again, it's essential for basic physiological life, such as for breathing, for heart rates and such. That's not going to, it's going to be unique. It's going to be important, but it won't be unique. So it kind of teases apart something that's sort of like in the new patterns that are in the cerebral cortex, which could be unique and which could be in very many cases unique, but may or may not be important, depends on what it's linked to. So Principle 5 is the reduction in energy difference is controlled by negative and positive feedback loops. We talked about that before. Physiologically, the eliminated needs such as heart rate, breathing, osmotic levels are controlled by negative feedback loops, whereas physiologically open needs such as those involved in the primary needs baseline activity level are controlled by positive feedback loops due to the inherent inhibiting forces of the residual incongruencies. So it's always going towards the primary needs baseline activity level. However, the inhibiting forces of residual incongruencies cause it to be limited. The fundamental energetics. This is kind of an engineering exercise just to show how what was just discussed beforehand can be put in a formalized system engineering terms. And you could just see again the 5 different aspects of a negative feedback system or a positive feedback system, for that matter. Depends on how you configure the system. And this was mentioned in the paper in charitiesoflife.com, where we're talking about Freud and how we can take what Freud was mentioning and also break it down into an engineering schematic. So what we have is, as mentioned, the TED, triggering energetics. Change in internal and external energy variable states is sensed receptor by one or more of the external sensory organs or internal receptors and translated into an internal sensory state that becomes a primary sensory pattern. And it can be a primary. It can be a primary. It could be also not just a sensory pattern. It can also be one for motor, but it is a primary input. So we have that one is again we're talking about uniqueness and important with the TED. You can look that over. And next, what we have is after that occurred, we'll have the frequency modulation, which gives you time that will have an even frequency of the inputs that are going to be experienced at the same time. Then we have amplitude modulation, and after that the probability of post-neuronal activity occurring given pre-neuronal conditions is varied by the amplitude modulation to a small extent so that the interference, which is noise, does not degrade the signal. Number 6, we go into momentarily small changes in pre-post neuronal patterns or creating those patterns that were affected by the change. This will briefly create a new internal energy state in these patterns and a component neurons and neurites. And so what we have here is that if the TED is met, if this new internal energy state created by an evoked pattern is greater than the TED as sensed by the hippocampus and associated structure, this is going to be the set point and integrator. Then the associations which created this evoked pattern will be strengthened. The effector. This may also lessen the difference between the non-optimal wants baseline activity level and the primary needs baseline activity level. You can see this on the diagram. So we have the system going along here. We have instantaneous incongruency, and if it goes down and it goes around across there, and if it comes back up, then the non-optimal wants baseline activity level might be actually higher. What we have here is triggering energetics. The question is this, that if the energy state is not below TED, then you'll be repeating steps 3 to 6. And you can see this is going to be on the next page, is that we had the non-optimal wants baseline activity level, and it does go down. However, it stays down because the evoked pattern, which is on the bottom, wasn't the necessary type of pattern to cause the energy to be above the TED, so it just stays down, and the non-optimal wants baseline activity level is actually further away from the primary needs baseline activity level. So this is something very important on this one. I'll just read it through. As shown in the previous diagram, those patterns that are not chosen will be temporarily hyperpolarized, more negative, and therefore less likely to have a lower probability to be re-stimulated and chosen until their rest potential is stored. However, due to the heterogeneous types of neurites involved, the length of time hyperpolarized or negative in each part of the patterns will not be equal, implying that some neuronal units can be re-stimulated before others. Nevertheless, and this is very important, when all units return to resting potential, the initial level of certainty will be reinstated. You'll be seeing that in our diagram coming up. Before doing so, I just want to talk about parallel processing. Given the central limit theorem, the mean of a sufficiently large number of independent random variables is such that the activity is given off by a neuron, each with finite mean invariance, will be approximately normally distributed. That implies that the change in probability from a certain state will achieve an average and not have an additive outcome. For example, if the noise in each unit is 2% of signal and there are 100,000 units, the outcome is 2% noise and not 200,000% noise. So in this one, if you're going to be looking at the bottom of your primary sensory pattern, which can also be the primary input pattern, you have 100%, and if you go through one layer of processing, because of the 2% noise, you'll have 98%, not a exponential reduction because of each one of them being additive to the other one. So this would be just the first layer when you're having at this processing level, you have them being basically all the inputs are going to be at the same time frame because of the V1B layer, and also at the same time it's going to also be modulated, and the modulation is going to be the amplitude modulation is what it's going to be decreasing from 100% to 98. So this is going to be also the idea of serial processing. Before it was parallel, they're all in parallel, but also the idea of serial processing we'll see in the next diagram. But let me read this for you first. If processing and originating TED continues, the change in the probability from the previous parallel grouping is added in series to the next parallel grouping. Between the change in the probability from the 100% condition of the primary input pattern, there is integration, a cycle which will continue until the evoked pattern's energy is greater than TED, or all the initial units return to resting potential, as was mentioned before. So what we basically have is the same layer at the very bottom there, and the little circles are saying which of the units within that pattern are being, which units are part of the pattern. As you go higher up, the individual units change. Some come in, some come back. And it's only until it reaches at the very top that, given the time function was mentioned before, that you go back to actually 98, because what's happened is that all the original change or noise that was there, and they have been hyperpolarized, they've actually repolarized back to their resting potential at the very top, and because of that, the additive probability changing from 100 to go down has actually been reset because of the time. So let me just read this for you. Once the originating probability for a certain event is decreased, or an unpredictable event, by the cycles of the process, the outcome will be nonlinear and uncertain. This was mentioned in the previous presentation about entropy. So this entire system, whenever you're having something that is separate from the environment, as regulating itself, it's going to be de facto nonlinear, but also when you have enough of a change in the probability from the original state, it can also become uncertain. So we're going to go into this one as well. Depending on the amount of noise generated at each cycle, each level of parallel processing, which is going to be a rise, which is going to be change, the generation of new pattern and testing it against the TRD, which is going to be run, which is going to be integration at different slope is produced. Moreover, due to the time-dependent nature of repolarization of the previous patterns, thereby limiting the additive effects of the in-series processing, the steeper the slope, B, which you'll see in the diagram coming up, the more likely an uncertain event will be created, while the less steep slope, C, will create more certain outputs. You can see this with the slope and repolarization. So B, where you're having the rise, which is going to be indicative of more change, it's going to be causing it to rise quicker, which will lead to more uncertainty than either to A, which is going to be a condition with rise and run is equal, or C, where the run is going to be a lot more than the rise. So in situation A, they're equal, rise and run is equal, change and integration are equal to each other, and so it's going to have the slope that's indicated here. Then B, because the change is so much more dramatic, it's going to be able to reach higher levels of uncertainty than something like C, which the integration, which is going to be having after the energy has allowed it to change, comes back to a state, and that state is for the time period before it gets changed once more, it's going to be at a stable state, but that stability causes it to take longer to occur. So by that time, all the original processes that were chosen for that pattern would have gone back to the resting state, so it would have not reached a higher level of uncertainty than B would, which in that situation, because the change is so much more dramatic, it can go through higher, more uncertainty. So the conclusion on this one, FAM is a nonlinear process that primarily produces frequency-related noise, setting up specific frequencies that input is experienced at a specific time, which is specific pace, which is time. This has been discussed before. FAM is a nonlinear process that secondarily produces amplitude-related noise, and this is going to be the instantaneous incongruency, which is kind of one of the cornerstones of what we are, who we are, is at that level of instantaneous incongruency. That which pushes us forward into what we're doing is a secondary function of the FAM process, which primarily does the frequency-related noise that allows for specific frequency, which is what we experience as time. A secondary thing to that is going to be the amplitude-related noise, which is instantaneous incongruency. And at birth, we have that instantaneous incongruency, which leads actually to residual incongruency also occurring, and that's throughout our life is what we try to actually overcome, which was also discussion shown in Maftio's analysis on a group of presentations that I gave a little while ago. And the third conclusion is FAM processing and its interaction with input, as well as with internal set points, is controlled by positive or negative feedback loops, can decrease the negative interaction between externally derived patterns stored in the system. The primary needs baseline activity level is set before any of these patterns are actually implemented or produced. So these are patterns that are going to be actually coming from external sources. So when you start getting these patterns that are linked to external sources, you go from primary needs baseline activity level to the non-optimal baseline activity level, and that's the drive to go back towards it. And so this is kind of an overview of how FAM brings together the previous ideas and the importance of how the patterns actually do change, because on the original presentation of this, the paper that most of this work was derived from, the significance of amplitude, the significance of amplified macroscopic probability optimization of learning, basically came up with the idea of using a physical event moving, which amplifies probability, and you can see how in that occurring we get time, we also get the variance, the original change, and also later on what we have is that reintegration in between, when the change between the frequency points goes back down to normal levels. So as thought is, we have the change and we have the reintegration or integration, and it goes back and forth, and depends on how quickly that changes, with the ratio between change and integration occurs. We can have higher levels of uncertainty, which in our previous presentation we talked about the idea of entropy, external entropy being overcome by internal entropy. So external entropy has its own linearity, and the internal entropy has its own linearity. So to the external events, the internal linearity looks nonlinear, and also the internal events, as I was showing you, that becomes more and more uncertain. Depends on how many levels of series of parallel processing that occurs. So hopefully that gives you a better understanding in engineering terms how the previous information can be developed towards a more mechanistic way of looking at these things, and how it can be developed into a more systematic approach. Thank you very much for your time. If you have any questions, please contact me at www.charitiesoflife.com. Thank you very much. Goodbye.